Today's lesson is on graph behavior. We're going to describe behavior of graphs, but we're also going to talk about intercepts and average rate of change of functions. So for starters, we're going to graph this function, and in this class we will have opportunities to use graphing calculators to graph a lot of functions. Some will definitely be done without calculators, but for this lesson, we can go ahead and I want to review using our graphing calculator. So you can go in your y equals, you type in the function, check out your window, and you can hit graph. But we want to look at actual table values. So remember, you can go under your settings and then actually see your full table, and then you can plot some of these exact points. So what I did here is I just used the points on the table and I plotted them, and I got to sketch a graph of this function. But now I want to talk about y-intercepts and x-intercepts. Well, if you have the graph, you can clearly see where it crosses the x-axis and where it crosses the y-axis. But what I want to do is talk about how to find x and y intercepts without the calculator. So let's think about what an intercept is. A y-intercept would be a point on the y-axis. That would be the 0 for the x value, and then you'd have to find the y value. But an x-intercept, which we sometimes refer to as zeros, is on the x-axis when y is 0, and we'd have to find the x value when y is 0. So using the same function here, let's plug in our zeros and solve. So when x is 0, that would be saying f of 0. So plug in 0, negative 0 to the third, plus 0 squared, plus 6 times 0. Well, that's easy. F of 0 equals 0. So 0, 0 is the only y-intercept, which we can see is right there. Now, finding the x-intercepts can be a little bit trickier. We're going to plug in 0 for y. So this time we're setting the function equal to 0. And then we have to solve. So all different types of functions. In Algebra 2, you learned all different ways of solving these. So you'll have a variety of examples in your lesson. But for this one, this polynomial, I'm going to think about factoring. I'm going to factor out a negative x, which will leave me with positive x squared minus x minus 6. But now, this is a quadratic that can be factored more. That can go down to x minus 3 and x plus 2. So now zero product property, I'll have three solutions. X will be 0, x will be 3, and x will be negative 2. So those are x-intercepts. Let's go look at the graph. There's my negative 2, 0, and 3. So you can clearly see those on the graph. So understanding how to use the graphing calculator, but also how to find certain pieces of the graph without a calculator. Okay, next part of the lesson is pretty easy. Looking at a graph and knowing where is it increasing, decreasing, and constant. But we're going to bring back interval notation. So to describe the interval where this graph is increasing, well, let's just look on here. It's increasing here and here. But the interval, when you're writing the interval, we're looking at x values. So it's increasing from negative 6 to negative 4. And it's including both of those points. So I have brackets increasing from negative 6 to negative 4. And then it's also increasing from 2 to 3. Okay, where's the graph decreasing? Clearly decreasing here and here. We want x values. So it is decreasing from negative 1 to 2, including both, and then from 3 to 5. And now where's the graph constant? just this one here, one interval here from -4 to -1. So this is pretty easy, just describing graph behavior, but using the interval notation and just remembering that intervals are always referring to the x values. And now the last part of the lesson is on average rate of change. So first, just some review. We're going to go back to Algebra 1 when we had a linear function and we knew two of the points on that linear function. The first point, x1, y1, and the second point, x2, y2. To find the slope of that line, we would say, oh, the slope m is the difference in our y, y2 minus y1, over the difference in our x, x2 minus x1. You probably should have seen change in y divided by change in x. Finding this change, this slope, is finding the average rate of change of this line. So I'm going to show how we're going to apply this to different types of functions, this idea of this average rate of change of nonlinear functions. So I'm going to write another formula that basically means the same thing as this. So average rate of change, we sometimes will just call it AROC, is f of b minus f of a. What are those? Those are y values over b minus a. And what this is finding the average rate of change of a function from interval a to b. Once again, these two are saying the same thing. This is still the change in y divided by the change in x. So for the graph, go ahead and pause the video and get this graph sketched on there. Don't worry about the actual function equation. We're just looking at the graph for now. So let's say we have this polynomial graph and we want to find the average rate of change on the interval from -7 to 5. So -7 to 5, those are x values. So -7 takes me to this point here. And then 5 takes me to this point here. So from the interval -7 to 5, what is the average rate of change? So that simply means if I connect these to make like this linear line, and I find the rise over run of that line, that's giving me the average rate of change of this graph. And this is called a secant line. So to now actually calculate it, let's see, I have the point, the left point is the point -7, -4, and that right point is the point 5, 9. So to calculate the average rate of change, we have to do the change in the y, 9 minus -4, over the change in the x, 5 minus -7. So we should get 13 over 12. Okay, and the last example is, okay, what if we have a function and not a graph, and we still want to find the average rate of change? But we want average rate of change over an interval. So let's say it's from the interval from -2 to 5. So think about from the interval from A to B, and I want you to go back to this formula. So to find this, if I'm going to do f of b minus f of a over b minus a, my denominator is easy because I have those, a and b, -2 and 5. But how do I find my numerator? Those are y values that you get from plugging these into the function. So f of 5 minus f of -2 all over 5 minus -2. And when you plug in 5, you should get -85. When you plug in -2, you should get 6. So -85 minus 6 all over, that's going to turn into 5 plus 2, which is 7. -91 over 7, which is -13. So that is the average rate of change of this function on this interval. So there's your full video on graph behavior, finding intercepts, and average rate of change. Good luck.